So this presentation is about covalent bonds and the properties of compounds that contain them. Concepts in this presentation are going to be what is a covalent bond, what is a molecule versus a formula unit, and finally, what are some properties of molecular substances. Let's start off with a vocabulary definition. What is a covalent bond? It's a bond formed between the sharing of electrons between two nuclei. This occurs between two nonmetal atoms. So let's take a look at a bond formed between the nuclei of two nonmetal atoms. We have a fluorine atom and a chlorine atom. The fluorine atom protons in the nucleus, 9 of them, are pulling on the shared electrons. And in the chlorine atom, the 17 protons in the chlorine nucleus are also pulling on the shared electrons. The number of valence electrons that chlorine had to begin with are 7, and the same with the fluorine atom. And they are sharing 1 electron from the valence shell with each other, and that creates 8 valence electrons for each of them. Let's look at that a little closer. You can see that the fluorine atom has 8 valence electrons around it, and also the chlorine atom has 8 valence electrons around it. This is the octet rule, and for any type of bonding, including covalent bonding, we are going to obey the octet rule and form an electron configuration that is the same as the nearest noble gas. We can draw a Lewis dot diagram of the compound between two nonmetals instead of doing the large Bohr model, and the shared electrons are between the two atoms, and you can see easily here that both have the octet rule applied to them. They both have 8 valence electrons, and that makes them stable. We can replace the 2 electrons that are between the atoms in the bond, and it makes a line diagram like this. In our previous example of fluorine and chlorine, each of those atoms had 3 paired electrons and 1 unpaired electron. In oxygen atom, you have 2 pairs of electrons and 2 unpaired electrons. The 2 unpaired electrons can bond with other unpaired electrons in other atoms. So in the case of oxygen, you would have the 2 unpaired electrons finding a partner with the unpaired electron in another atom of oxygen. Those electrons get moved to the center between them, and you will see that they are forming a covalent bond. Now, each atom of oxygen, again, has 8 valence electrons, and they are stable. Again, we can replace the pairs of bonded electrons with lines. Okay, now we have talked about what a covalent bond is. Let's move on and see what the difference is between a molecule versus a formula unit. So in this picture, we see that we have an ionic compound, and this ionic compound is made up of ions, obviously. But there are no discrete units that make up the ionic compound. All the ions are formed in a 3D regular repeating pattern. So this ion, this positive ion, is attracted to the negative ion next to it just as much as another negative ion that is next to it. We can't say that these 2 ions belong to each other any more than we can say that these 2 ions belong to each other, or that these 2 ions belong to each other. They are all connected together into one large crystal structure. However, when we look at covalent compounds, they form molecules. And so you can see these 2 white atoms are covalently bonded to this red atom. Now, this white atom may be attracted to the red atom in another molecule. However, it's not as strong of an attraction. So that means that this white atom belongs to this particular molecule. And then another white atom will belong to this particular molecule. They're discrete units. And that's the difference between a formula unit and a molecule. So covalent compounds, we can call them molecular compounds as well. So that's what the difference is between a molecule and a formula unit. Finally, what are some properties of molecular substances? They're a little bit different than the ionic properties that we have previously learned about. So we'll look at the melting and boiling points. We'll look at the states of matter at room temperature, the hardness, and the conductivity of heat and electricity in molecular compounds, those that have covalent bonds in them. So let's look at the melting and the boiling points of molecular compounds. They are lower than ionic compounds. So water, which is a molecular compound, it melts at 0 degrees Celsius. This is a lot lower than salt, an ionic compound, which is melting at 108 degrees Celsius. Molecular compounds exist in all states of matter at room temperature, whereas ionic compounds were typically a solid at room temperature. So this first picture shows an aluminum boat floating in a sulfur hexafluoride gas at room temperature. Sulfur hexafluoride is a very dense gas. We have a glass of water, which you're very familiar with. It's a liquid at room temperature. And finally, a crystal of silica, which is a solid at room temperature. This is a molecular compound, even though silicon is not a nonmetal, it's a semimetal. But semimetals have properties of nonmetals as well as properties of metals, and so it forms covalent bonds with oxygen. And then molecular compounds have varying hardness as a solid. So a solid paraffin wax is quite soft and can easily be pushed around, and that means pliable. And then solid water is hard and brittle, as you know. Ice breaks off quite easily, and it's hard. They're both molecular compounds. And finally, molecular compounds do not conduct electricity or heat very well. The reason they don't conduct electricity, as you can see, the light is not turned on when we use sugar, which is a molecular compound. It's because even though these molecules, when they're dissolved in water, can move around and they're mobile and they can travel through the solution, they do not have charges on them. And you need a mobile particle, such as an ion or an electron, to move around, and that will be able to conduct electricity. But these are neutral, and they cannot conduct electricity. And that's the end of this presentation.